One of the things that I also want to sort of drive home here, people ask me a lot, oh great, Hadoop is so much bigger and it works with so much more data. Can I stop paying my database vendor all of that money that I pay them? And the thing you understand is Hadoop's not a database. It's not designed to replace the database. It doesn't do what your database does well. But Hadoop is a very powerful batch data processing system. But some of the things that you need to understand about Hadoop is that it does not process data in real time. So you will never have like your interactive users on your website interacting directly with your Hadoop cluster. What you're going to see happening is your Hadoop cluster absorbing data from many different sources and processing that data in ways that you care about. Now the output results of that may get loaded back into your interactive databases that do interact with users and allow you to do things like make better recommendations, understand sort of user behavior better. You see a lot of things where you start typing into search boxes and it starts sort of completing your queries for you. Hadoop can generate the indexes that do that sort of thing. It augments your existing databases. So it is a new piece in the puzzle here. But when people ask about cost, one of the things that I like to say is that oftentimes you'll see people storing way more data in the database than the database is good at storing. Okay? So one of the ways that you can lower your cost with Hadoop is, maybe right now you're storing, I don't know, 10 terabytes in a database because you need to make sure that maybe you only use 1 terabyte of that actively, but you need to make sure when you have a question about that other 9 terabytes that you've got it there. All right? Well, maybe what you can do with Hadoop now is, you've got that 1 terabyte of data that's hot, that you need to be, have your transactional consistency on, that you need to be working with in real time. But maybe that other 9 terabytes you can dump into Hadoop. And yeah, it's going to take you a little bit longer when you want to ask a question about it. But I guarantee you that you will save orders of magnitude on your cost because you're not using high-end servers to store this anymore. You're not paying license fees for the per terabyte license fees. You're really aligning your costs with commodity storage and utility computation. The last thing you need to understand that I hope you take away is that Hadoop enables deeper and more flexible computation. But the thing is, though, if you take away nothing other than these 3 things, then I've done my job with this part of the talk, is that you can really just do a lot more with Hadoop than you can do. You can ask questions that you aren't even really familiar with the possibility of asking. So you really want to rethink the kinds of questions that you can ask. So I'm going to try and drive this home and get a little bit more sort of technical and a little more compare and contrast here. So I like to start this with something that we all sort of wish we had here, was this beautiful Ferrari in the background here. And let's look at sort of a typical high-performance database and analytics architecture. And what I kind of want to talk about is how this limits actually working with big data. So if you look at this typical system here, you've got some enterprise website, maybe your Facebook, maybe your MySpace, maybe your, who knows what. You've got an interactive database that interacts with all of your users. And you generate a lot of data in this process. Maybe you keep track of every click, every poke, every, who knows what else you keep track of. And you want to shove this database into something like Oracle or SAP so you can do your analytics over it. What you'll quickly find is that you can generate way faster than you can do an OLAP load. There's a lot of things that happen when you load data into a database. You've got to build indexes. You've got to maintain relationships. You've got to ensure transactional consistency between everyone else that might be accessing that data. And you'll find that it's not actually that hard to generate more data than you can load. So then you have to make a decision. Well, what do I do with this extra data? Do I throw it away? Do I condense it? Do I just not keep it? Do I put it on a tape drive, which we all know you're never going to go and look at again if you put it onto a tape drive? Anyway, but when you get it into these Oracle and SAP systems, you can do business intelligence on it, and you can use all the tools that you're used to there. But what you're able to analyze and sort of glean intelligence from is actually a subset of your data. It's an aggregate of your data. You're throwing out a lot of raw event-level data, which you don't really know what's locked up in that. And maybe it's valuable and maybe it's not. But Hadoop will enable you to not have to make that decision up front because it's very cost-effective to store the data. Takeaway from this, because the data generation rate exceeds the load capacity, this will limit your consumption. It either already is or it will in the future. There are performance and cost considerations that you need to consider in this environment which will limit retention and analysis. And some workloads drastically impact performance. Like if you take all this data and you try and do things like sessionize it, and try and say, okay, well, for each user, I want a list of everything that they did. If you ever tried to do this query in your database, you'll see that it takes it to a grinding halt. And in the process, it's not doing any of the other things that your database is good at. So this will, again, limit how you use the database. So let's sort of look at this now. We've got Ferraris here. We know what Ferraris are very good at. They accelerate very quickly. They can do quarter miles very fast. They can go very fast at their top speed. They can start and stop many times in an hour. But let's look at this whole other model here is a freight train, which is just much more powerful. It will last for much longer. Throughput, it can move much more cargo through a distance in a given unit of time. And this cost basically for moving cargo is orders of magnitude cheaper. Now that isn't to say that Ferraris don't have a very valid place in the world. They're great for what they do. But at the same time, you wouldn't try and use that for any of these things that a freight train is really good at. So let's stop talking about Ferraris and freight trains now, and let's sort of bring these sort of models here back to some of the specific sort of technical issues that you're probably looking at in your data infrastructure here. Transactions per second. A relational database system will do thousands of transactions per second. It'll allow hundreds of concurrent queries. If this is what you're trying to get out of your data, this is what you need a relational database for. Let's look at something that Hadoop can do that these can't do. They can work with tens of petabytes of data. They can store this in volume. They could do a query that looked over this much data. And the flexibility that you get now. We can ask questions in MapReduce. We can use streaming. We can use Pig. We can use Hive. We're no longer constrained to a declarative language like SQL. We can ask arbitrarily expressive queries about our data. And these are the sort of places where they kind of overlap a little bit. And you need to sort of understand sort of the characteristics of your data here. What are your update patterns? All right, if your update patterns are read-write, a database is probably going to help you a little bit more here. But if this is an append-only workload where you can sort of always just write data onto the end of a file or add new records, or if you can always append and never need to sort of go back and update, absolutely you should be thinking about Hadoop. When you start to think about join complexity, if you've got all this structured data and you need to join 100 tables together, this is what databases do really well for. If you have a lot of structured and unstructured data and you don't know exactly how you want to join it up front, and you want to decide this later, like maybe when you actually collect all of the data, and then you want to decide how you want to join it, Hadoop's really good for this. Yeah, and it can allow you to do this over arbitrary keys. In a database up front, you decide, these are my primary keys, these are my foreign keys, these are the ways I'm going to be able to join my data. Hadoop, you don't have to do this up front. As you process your data in the map phase, you get to, at that time, define what the keys are that you're going to join over in the reduce phase. And they can be different for every job. They can be different for every data source. They can be different for every sort of data processing pipeline that you go through. And it takes a little bit of a while to sort of wrap your head around this flexibility, but the take home is you can do virtually anything you want. And that's, the last thing that I like to point to people here. Let's look at some of these hardware, profiles and sort of cost structures here. With databases, we run typically on high-end servers. The database servers are often the most beefy, expensive servers that you're going to have in your operation here. Hadoop primarily runs on commodity utility servers. You can buy cheap pizza boxes. You can run on Amazon EC2. You can, use a managed hosting provider where you can sort of, rent computers by the month. You don't really care what type of hardware you're running on. And the cost structure is very different. With database systems, you typically pay some upfront licensing plus annual maintenance. Hadoop's free software. And if you want to buy support for it, many enterprises do actually like to pay for software, even when it's open source. That option is available to you. If you need sort of that kind of reliability, that is available. But if you have a team that is capable of doing this and really want to invest in all of that work yourself, that's an option you have as well.